Hello everyone, this is Shankar. Hope you are doing well. In this video, I will explain about how future works in Java asynchronous plus blocking approach, right? So let's get started. This is not a sketch video. It is the part 2 video feature interface explanation. This is the first video. It is the future video. It is the second video. In post video, we have developed this piece of code. In that piece of code, we have done the addition operation. We have done the addition operation. It is a single thread we are used. In this second video, I want to do three operations like addition, subtraction, multiplication, like three tasks I want to create. In this video, we are created just one task. We are submitted one time. Execute service dot submit one task only we are created, right? In this video, three tasks I want to create. So let's get started. If you are not watched this video, please go through. Here I am explained what is the future interface, how to blocks asynchronously like that, right? So I will create future test 2. Future test. Assume this is a second video, second class like that. So now compared to this code, I will slightly change the way of development. Okay. So post. Let's find out the CPUs available in my system. CPU cores available in my system. Runtime dot get runtime dot available processors. It will find the cores, CPU cores. Suppose int cores equal to. Let's add a comment. So thread pool based on CPU cores. So let's pass this integer this variable to the new fixed thread pool. So executors 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 dot new fixed thread pool. Let's pass cores. It will return the executor service. What it will return? Executor service. Executor. It will return the executor service. Let's take variable as a service. So this is done. Let's add task 1. What is that? Addition. Addition. Addition, right? What we need to do? Service dot submit. Service dot submit. So this is the callable task. Lambda expression used. Callable have only one call method. So it is a functional interface. Wherever functional interfaces are available, so we will use the lambda expression, right? Some system dot out some message had executed by. So let's print it thread, which thread is executing, plus thread dot current thread dot get name. Get name. So return. Let's create one static method. Public static int add int a comma int b. So return a plus b. So this is the let's take static methods we can call by using directly by using add, or we can call by using the class name. Suppose let's pass like a 10 comma 10 comma 50 semicolon. This is the done, right. This is the addition task. Like this, let's create another task. Task 2. What is the subtraction or multiplication? Let's take multiplication. So now service dot submit. Here callable, so applicable lambda expression. Lambda syntax look like arrow mark. If multiple statements are there, we need to use bracket. If single line, not require bracket and return type. Now here add executed by, right? Multiply, multiply executed by, multiply executed by thread dot current thread dot get name. So next return, return multiply. So let's add 10 comma 50. This method is not available. So let's create one multiply method. Public static int multiply, multiply int a comma int b, return a star b multiplication, right? So let's change to private. This method we need only this class, not required to access. We are not supposed to access this method in other areas, other places. So we can also like this, or we can also use class name also. If you want also class name, we can use. Static methods we can call by using class name or like this as well, right? Static import. Both ways we can achieve. Third task, task 3, subtraction. Subtraction, right? Service dot submit. We need to pass the callable. Callable as the functional interface. It has only one interface, so we are using the lambda expression. Wherever functional interfaces are there, lambda expression is applicable, right? So no thread dot current thread dot get name. So three tasks. A recent task are thread one thread. This is second thread. This is the third thread. Were created, right? So let's run. Up to let's run. What happened? We are so the three threads executed at a time, right? The three threads are executed. So let's add here. In addition, let's add thread thread dot sleep. Suppose this means 10 seconds. We are setting. We are saying wait for sleep for 10 seconds. Let's see. So these two are completed. Three tasks are executing parallelly. These two are completed. Post one is waiting. Waiting. After 10 seconds, it is completed, right? So let's command this thread dot sleep. So now let's use try and catch. We need to handle manual exceptions manually, right? While using the future, right? Exception e exception e dot print stack trace, right? Here let's take three sysouts. First one is the so add result add result dot so see these are the three tasks were not stored in any variables, right? So let's store here future of integer name like a add future control shift O for enter for imports. Feature is a interface. Let's take here future of integer. It is the multiplication, right? Multiply future. This is the future of integer. It is the subtraction future. Subtract future, right? So it is the subtract future, future integer, subtract future reference variable, control S. So here we are forgetted to return, right? Return, we are not added subtract method, I think. So let's add subtract method. Subtract, subtract is minus. So we are subtracting b minus a, 50 minus 10. So subtract 10 comma 50 semicolon. So here add future dot get. See, get two overloaded methods are there. We are using the post one get. So next system dot out dot println multiply, multiply. So multiply result, multiply result. Suppose multiply future dot get same another. So subtract, subtract result plus subtract future dot get. So this is the future call. This is the future call. It is a, like a asynchronous plus blocking. Future call. Suppose async plus blocking call. Async plus asynchronous plus asynchronous plus blocking call. Next, let's check the three threads are completed or not. After get get call get call all tasks completed. We are checking it is really completed or not. So now yeah done. Is it is addition operation is completed or not? So now add future dot is done. Let's copy paste. It will save time. So multiply, multiply, multiply done or not. Multiply future. Next subtraction, subtract, subtract is done or not. Subtract future. So let's up to I will run a Java application. So it is giving immediately right result. So slash n for some space. Run a Java application some space. So here also one slash n some space. Run a Java application. So it is giving it is work executing like a parallel. So there is no sequence one by one, right? So now do one thing. Let's task one. It is the addition. Let's do let's 10 seconds sleep. So see these two are executed. Multiply executed by subtraction executed by. This is like tasks are submitted. See result these three tasks are submitted. These two tasks are submitted. Otherwise do one thing. Do one thing. Let's cut this area. So run as Java application. So three tasks are submitted, but these two are so three tasks are submitted in addition operation. I am setting sleep for 10 seconds. So now here multiply and subtraction also waiting until completion of post task, then only result is printing, right? So it is the blocking mechanism. So it is a blocking mechanism. So waiting for addition result of this multiply and subtraction. Once this addition is completed, then only these two remaining are executed, right? It is done. See here, this is the red color. It is still like a listening mode, running mode kind of. To we need to shut down thread pool manually. So service dot shut down. We need to do shut down manually. Now let's run a Java application. See, these are the tasks are submitted. So post it needs to be executed in order like task 1, task 2, task 3. Task 1 we are setting waiting time like a 10 seconds. So the, the multiplication and subtraction are waiting until first result. Once first result is available, then second third is executed. Let's see. Let's change this thread dot sleep. This let's add in the third one. Like third task means this is the subtraction. So post 2 it will give result or it will wait for the third one. Let's check. This is the task 3. See, 3 tasks submitted. Post 2 tasks are giving result. Third task is so waiting for the third sleep. We are set to sleep for 10 seconds. So that means we are understand it is working as a parallel. So if post task is in sleep mode or some it is taking some time, remaining task responses are also on hold until completing the post task. So it is like a blocking, like a future dot get. It is saying block remaining threads until giving the response of current thread. So suppose if you want to we are set like subtraction task thread dot sleep 1000 seconds, that means 10 seconds, right? So what happened? First two are executed. Third one, it will be waiting. If it is first task is taking some time to execute, then remaining two are will be blocked. But if first two are executed quickly, then third one, third one, it will take some time. It will only hold, right? So in this video, what we have done, we are finding of the threads core CPU cores based on the three CPU cores. It will create the threads like 4 CPU cores, 8 CPU cores. If 4 CPU cores your system, it will create the 4 threads. If your system is 8 CPU cores, it will create 8 threads. After passing this response to the fixed new thread pool. By using thread pool, we are submitting the task. Once submitted, it will on submit method it will be there. It is accepting either callable or runnable. Both are written the future by using the future dot get we can block the thread. It will until completion it will block the remaining waiting threads in order wise 1 2 3. If you are if you are adding thread dot slip in post task, remaining task will be hold until completion of post task. If you are adding thread dot slip in last task only hold. So in this video we have successfully understand how future works in Java asynchronous plus blocking. Thank you for watching. Please subscribe for further videos.